Now we take up module 16 dealing with one of the topics that has been fairly discussed in the back, namely the randomized response technique. As we know, in survey sampling context, there could be occasions to deal with what are called qualitative characters or quantitative characters, but with a specific idea, namely sensitive issues. Whenever you are dealing with sensitive issues, direct response technique is not very profitable. Either the respondent will refuse to answer, or even if they respond, it might be a untruthful answer. To avoid that, we have discussed about some methods introduced originally in 1965 by Warner, called the randomized response technique. So, we had some idea about the technique and its application. Here again we revisit the problem, and here we find a blend of survey sampling and design of experiments concepts together. There are some design theorists who have ventured into this problem of randomized response technique and suggested uncommon estimation and sampling procedures. So, we will have a test of those issues in this module. I propose to take up a continuation to what we have discussed earlier, namely the randomized response technique RRT, and I want to discuss a method towards achieving more confidentiality on the part of the respondents. As you know, whenever we are dealing with sensitive issues, the whole concern is do I have enough confidentiality in the interviewing agency. So, I feel that my confidentiality is protected, and whatever I am telling, it should not be divulged at any cost to other people. That is the major concern of the people, because you are discussing about sensitive issues.
Sir, I have a request before you proceed further. I would like to describe in my own way what we've learned so far involving the mechanism of randomized response technique. There are sensitive features in the context of a survey, and we need truthful responses from the respondents. Direct questionnaire method seems helpless, as we expect more refusal or untruthful responses from the respondents. So we recommend randomized response technique, and Warner proposed that it's what is known as related questions method. According to this method, there is a deck of cards of two colors, say red and black, and for technical reasons, their distribution has got to be uneven. Red cards read like, I belong to category A, while black cards read like, I do not belong to category A.
Yes, as you know, this category refers to a sensitive category. Yes.
Here, category A refers to the sensitive category.
Right.
Each respondent is asked to draw one card at random and act accordingly. It is believed that by releasing information only on the eventual response, yes or no, and not on the color of the card randomly drawn by the respondent, his or her privacy is well protected, and truthful response will be provided by each participating respondent. Of course, you did mention that there are lots of variations of this method, and the methods also address the question of estimation of the total and mean of quantitative features.
You are right. Even though we discussed basically the question of estimation of the probability of a sensitive character capital A assumed to be binary response feature, but there are methods to handle the quantitative response as well. So, you have provided a fairly simple description of the basic RRT for eliciting information on a qualitative feature in terms of estimation of the population proportion of yes responses, reflecting the possession of a qualitative category. We are denoting it by character A. I will take up from here, and I will go for describing an RRT altogether different from what is usually done. Once more, let us note that usually a respondent is asked to provide response to a single sensitive question chosen by adopting the RRT principle from a battery of questions, related or unrelated questions. So, basically you have one single issue and one single qualitative feature which is sensitive, and you are supposed to give a response to yes or no through a mechanism where your privacy is protected. That is the whole idea. The technique to be discussed here is based on what is called a block total response. Let me clarify with reference to an example wherein the feature A refers to being drug addict, for example, to be identified as a sensitive feature. So, I want to know in a population of young college students what is the percentage of drug addicts, for example. It is a sensitive issue, I cannot go for any, I cannot prompt any direct response technique. So, possibly closely related features are among hospitalization at least once in the last 6 months, smoking habit, gambling habit, involved in road accident, which are likely to be less sensitive than directly hitting drug addict. So, these are the related questions which will lead towards the drug addict setup. And there are a number of unrelated features that one can list.
So let me make a guess, maybe wrong still, as you've said it is block total response technique. My guess is that the survey statistician will provide a collection of features to the respondents and ask them to provide only the sum total of the scores, assuming that each feature has a binary response. But then how do we take into account the sensitive feature A in the process? Okay, let me hear from you, sir.
Yeah, you are almost there. It is indeed true that the survey statistician will ask for the block total response, assuming that each feature has a binary 1 or 0 response. Now, we need to check the total collection of all features, including the sensitive features under study. Moreover, we need to sort out how different respondents would address the entire collection or subsets of the collections, including or excluding the sensitive feature. In this context, several design concepts have been incorporated. We will discuss about what are called balanced and complete block designs or BIBDs. We will refresh the definition of a BIBD in the language of an RRT. Thus, it suggests that we consider a collection of V features and a pool of B blocks, each block having K of the V features, such that eventually every feature is contained in exactly R blocks and a pair of features are contained in exactly lambda blocks. The blocks are subsets of the features. The blocks are of size k, each block has a collection of k of the V features, that is the whole idea. And then you can see what is going on.
Sir, if you do not mind, can I take up an example as an illustration? For example, let us adopt the BIBD with B equals 12, V9, R4, K3 and lambda 1 belonging to the OS1 due to Yates.
Yeah, that is Yates orthogonal series 1 that we took up in design. Yeah.
Then we're dealing with a collection of 9 qualitative features, each with a binary response, and each block has a pool of 3 of these 9 features, etc. To be more specific, let's go for these blocks and features. Sir, you may please continue from here.
Great. You have already taken care of some of my usual explanations. The intended method deals with 9 qualitative features and the extra feature capital A imposed from outside, and this blends capital A with the 3 features in every block. All these 12 blocks, they combine 3 of the 9 features. These 9 features are related to the feature capital A, but those are not quite sensitive. Those are auxiliary features in support of capital A, for example, the kind of examples that I gave earlier. And then those 9, so in every block I have got 3. Together with that, I append this, I blend this capital A in every block. Every block contains 3 regular features and this additional feature capital A. That is how it is formed. A block total response arising out of a respondent in block 1, for example, comprises of his or her response to the features labeled 1, 2, 3 and the additional feature capital A. So, all that the person does is looks to all these 4 features 1, 2, 3A, examines his or her status in respect of each of these features, has a score of 1 or 0 and the total score is reported. The total score ranges between 0 to 4. Additionally, so that is the end of the first part. Additionally, we take one block which is reserved for all the 7 features taken together without the feature A. We have got 12 blocks following the BIBD, and the 13th block, it has all the 9 regular features taken together. Usually, it is tacitly assumed that the pool of respondents altogether, capital N, small n, it has a representation like 12 times n star plus n0. Because there are 12 blocks, every block will have the same number of respondents, that number is n star, 12 times n star, and whatever is extra, that is n0, that n0 is supplied to the additional block, which has got all the features, all the regular features together. So it is assumed that the pool of respondents small n has a representation n equal to 12 times n star plus n0, so that the contents of each block of the BIVD are tested on n star respondents, and the additional block is used for the pool of the n0 respondents. It turns out that the block totals T1, T2, T12 and T0, the last one, they provide unbiased estimation of the proportion PA of the incidence of the feature A. There is a formula which can take care of all these things, and eventually you get an estimate of PA. It is believed that the adoption of this BTR block total response technique ensures increased cooperation from the respondents, and it ensures gain in perception of confidentiality of the respondents, where they are referring to a block total rather than any individual response. Earlier it was look at feature A and you tell me through this randomization technique, eventually you are hitting only one single feature, but this time it is a total.
Sir, it is definitely very interesting and instructional to see how researchers have strived to achieve increased perception of respondents' sense of perceiving confidentiality. Let me take up the computational part here for this example. We have as the expectation of T1, P1 plus P2 plus P3 plus PA, etc. till the end. Further, the expectation of T0 is equal to P1 plus and so on to P12. Therefore, the expectation of the sum of the TIs is 4 times the sum of the P's plus 12 times P of A. From the above, we have PA hat equals summation Ti minus 4 times T0 whole divided by 12. Sir, I believe at this stage it may be remarked that this estimate may suffer from being negative at times. There may be procedures to take care of that. For example, increasing the sample sizes n star and n naught would be one distinct possibilities.
Okay, let us go back little bit. In this, when you are talking about expected T1, T1 comprises of the features 1, 2, 3 and the sensitive feature capital A. Therefore, rightly T1 is the score, so expected value of the score is nothing but using indicator function 1, 0, P1 plus P2 plus P3 plus PA. That you do T1, T2, T3 all the way up to T12, and then you write expected T0 as well. Expected T0, that T0 contains all the regular features which are 9 in number. So, there is a typo here, it should have been P1 plus P2 plus P9, because there are 9 features. That is all that we have in the design. In the design we have got, let us see, in the design we have got 9 regular features and 12 blocks. Okay? So, it is T1, T2, T12, but the last one T0 that refers to only 9 regular features. So, that should be P1 plus P2 plus P9. So, there is a small typo here, but anyway you write out expected value of summation Ti, all those things, because each feature is coming 4 times replication, that it is 4 times sum of all the P1, P2, P9. That plus 12 times PA, because this PA is coming 12 times in each of these T1, T2, T12 it is coming, that is plus 12 times PA. So, it should be P1, P2, P9. And then what you do, from summation Ti you take out 4 times T0, this is coming from T0 and you divide by 12, and that should be 12 times P, then divide by 12 and you get the result. Okay. So, as I said, there is a small typo here, because there are basically 9 features along with the sensitive feature capital A, therefore, Pi should be P1, P2, P9. So, expected T0 that should be P1 plus P2 plus P9, and therefore, expected value of summation Ti, that expression is fine, because you have got 4 as the replication number for each of these features, 4 times P1 plus P2 plus P9 plus 12 times PA, because T1, T2, T12 there are 12 of them, and A is accompanying everyone. And therefore, this is the expression that you get at the end. This summation Ti refers to 1 to 9. And then, so yeah, please continue. Oh, you have, okay. So, you wanted to know if there is any possibility of increasing the precision by increasing sample size n0, n star and n0. N0 is the common number for the additional, and n star is the number for every single block. So, whatever you have said goes uncontested. Naturally, there are ways of increasing the precision by increasing both n star and n 0. I am happy to see that you are in a position to judge the merit or demerit of the procedure yourself. However, don't you think that a handful of only 4 features are not likely to provide any gain in perception of increased confidentiality in the minds of the respondents at large? All we are saying is that start with a BIVD with 12 blocks, each block of size 3. So, those 3 are regular features, append the sensitive feature A. So, 3 plus 1, 4. So, in every block you are asking a respondent to give a total count, block total response only based on 4 features including A. Is that enough? Of course, we are not referring to the N0 respondents at the end who are dealing with all the 9 features, but there is no challenge there. Well, that part is simple because there is no sensitive issue either. Those are all regular features. They should have a feel good attitude after all those individuals. They do not have to respond to the sensitive issue. But the upper part, I am including the sensitive issue true, but that is along with only 3 regular features. So, is that okay, or could I do anything better?
Now that you mention about this possibility, I buy your point, sir. Yes, there is merit in this approach, provided the block size k is reasonable. What else could be done otherwise?
The latest approach is like this. For every block, consider the complementary collection of V minus k features which are left out and blend them with the feature A, so that these are V minus k plus 1 in number. So, in the first part you have got k contents of the block, there are k features. In the second part you are only talking about the feature A. Now, you also append all those V minus k features in the complementary set together with A. You have got V minus k plus 1 features on the right hand side. Ask each respondent to respond to all the k features from the main part and choose only one feature out of these additional V minus k plus 1 features, including the feature A. Choose one out of these and then respond to that question as well and eventually give the total. Finally, all that the respondent provides is the extended block total response and no details whatsoever. So, in this sense, the earlier approach may be referred to as supplementary block total response. I have a block, I am supplementing the block by using capital A and then I am calling it a supplementary block total response. That was the earlier method. The latest recommendation is extended block total response. So, along with that k, you pick up 1, not just A, but 1 out of V minus k plus 1. So, then you respond to k plus 1, but that one is picked up from a larger collection. That is to give you more confidentiality and more satisfaction that my privacy is really protected because I am picking up 1 out of so many, and that A may or may not be picked up. It may also be noted that while making a choice of one feature out of V minus k plus 1 features in the extended supplementary block, the feature A may be assigned a different probability, say theta, as against the probability 1 minus theta over V minus k attached to each of the rest. There are V minus k plus 1 in that extended set. So, out of that, for the feature A, I assess a probability theta for selection. For the remaining 1 minus theta over V minus k, equal probability to the rest. And eventually I am making a selection of 1 out of them, that along with k, that makes k plus 1, and my block total response is based on k plus 1. That is the idea. It is not a difficult task to analyze the data resulting out of these BTRs and arrive at an algebraic expression for unbiased estimate of PA. It goes without saying that the survey statistician is continuously trying to make sure that the respondents feel more and more comfortable in releasing information on the sensitive feature capital A, particularly for those in the population who do possess this feature. The problem is only with those who are really possessing the feature. For those who do not possess, they do not mind, okay, because anyway they are saying no. If it is selected, they will say no. But for those who are possessing this feature, there is an apprehension that my God, maybe it may not be possible to protect my privacy. So, they have to be satisfied, and that is why you are giving so many alternatives to make sure that they really feel comfortable. Okay, so let me stop my deliberation at this stage. Yeah, to sum it up, in this module 16, we revisited this RRT technique as was proposed by Warner and as was briefly discussed in one of the earlier modules. We took it up and we are always trying to make sure that the respondents they feel more and more comfortable in divulging the information regarding their possession of the sensitive attribute. So, we talked about what is called a block total response technique. Instead of responding to only one question out of a pool like that, let them respond to a total, and that block total is coming out of the concept of BIBD. You bring the concept of a BIBD, you bring the concept of a block, then you talk about the supplementary block total response technique, extended supplementary block total response technique, and these are all geared towards giving more and more protection to the respondents. So, we will stop now and we will look forward to some of the interesting exercises and MCQs. Let us take up some exercises. Question 1 reads like, for the BIBD 12, 9, 4, 3, lambda equal to 1, looks like the same BIBD that we are talking about anyway. For this BIBD, analyze the data given below, assuming that supplementary block total response technique has been adopted. So, we know what we mean. In the first part we have got a block of size 3, to that we add the sensitive issue A, it becomes 3 plus 1, 4, and out of that you give a score. Each one is a binary response thing. If it is yes, you have a score of 1, otherwise 0, you just give the sum total. As you know, the sum total will range between 0, 1, 2, 3, 4. So, there is a total of 1000 respondents, and because there are 12 blocks, each block has got 75 respondents, 75 into 12, 75 into 12, that makes straight away 900. So, only 100 is left, that 100 corresponds to the additional block or the master block N0. So, 100 respondents, they have to address all the 9 questions and give a total count. But these 9 they do not mind, because these are all regular features. And in each of the blocks, we know that there are 75 respondents in each block, and every respondent has to answer to 3 plus 1, 4 questions. So, these are the blocks 1, 2, 3, 4 up to 12. Additional block, because additional block has got all the 9, therefore, the total score will be between 0 to 9. Is that clear? Frequency distribution of scores underlying the block total responses. Let us see, all the 12 blocks on the top, each one has got a score of, for every individual the score is between 0 to 4, because there are 4 questions. So, the score is 0, 1, 2, 3, 4. Let us look at the first column, the second column I mean, block number 1. The questions are 1, 2, 3 and A, and there are 75 individuals responding to these 4 questions. So, I have a frequency distribution of the scores through BTR for these 75 individuals addressing the questions in block 1. So, what is the lesson? The score of 0 for 5 individuals out of 75, score of 1 for 15 out of 75, score of 2 for 30 out of 75, score of 3 for 20 out of 75, score of 4 for 5 out of 25. Out of 75. So, every column has a total of 75, 75, 75 till the end. Is it clear? That shows the frequency distribution of the BTR score. This is the score distribution, and the additional block had altogether 9 questions, and there are 100 individuals. Each individual responds to all the 9 questions. Therefore, the score distribution now goes from 0 to 9. For 0 the frequency is 5, for 1 the frequency is 8, for 2 the frequency is 17, for 3, for 4 I have captured up to 4, then I have been clear enough in saying what is there for 5, what is there for 6, 7, 8, 9 for a total of 100. So, the last column corresponds to the extra block that we are referring to, corresponding to all those 100 respondents. Okay? but they are talking about straight game. For them it is a straight game because there is no sensitive issue involved. This is my data, the data matrix, so to say, and all you are supposed to do, you are supposed to use this data, analyze the data, and then come up with an estimate of probability of A. That is the whole idea. What is the next question? Please read.
Work out data analysis of the BIBD with extended supplementary block total response technique being adopted, taking theta as 0.40. You may assume the same data set as in the above table.
Very good. So, let us try to understand what is happening. This time it says that you go for extended supplementary block total response. So, in the first block, I have got the regular features 1, 2, 3 together with A, that is what we had under supplementary. Under extended supplementary, out of 9 regular features, 3 are captured in the primary part, 1, 2, 3 for block 1. So, all the remaining 4 through 9, they are covered in the secondary part along with A. So, 6 plus 1, 7. There are 6 regular plus A, there are 7 in the supplementary part. So, in that supplementary part, out of those 7, you apply 40% chance to A, selection of A. The remaining 60%, there are 6 of them, 6 into 0.1. That means each of the remaining 6 regular features, they get 10% chance, and this capital A gets 40% chance. You use that technique in every block for every respondent. This is a simple minded regular randomization that you are adopting. But in the process, people will make different choices, and people will some people will be addressing question A because they will be selecting this, etc., etc., and you use the same data as you have here. Pretend that the same data has been obtained by adopting this extended supplementary block total response technique. We know how this method is working. All that we needed is a choice of theta, and that choice is given. Okay? You are supposed to work out the details and then provide an estimate of PA. What is the next one?
Examine the necessity or otherwise of use of a BIBD rather than an equi-replicated binary proper block design.
Okay, so let us try to understand. This design that we used was a BIBD, balanced incomplete block design. We had equal replication for every feature. Each of these 9 features had equal replication. It was a proper design because every block had same number of features, regular features, and it was binary. Either a feature is included in a block or it is not included. It's not that it is included more than once, which does not make sense. But if we what was extra of that? That any 2 features occurred together in lambda blocks. That was the additional property of a BIBD. But in the analysis that we have indicated, taking the total and doing algebra, nowhere lambda was coming into the picture. So, maybe that we do not really need to use a BIBD. If we simply have equi-replicated design, all the features are replicated equal number of times. It is a proper block design. Every block has the same number of regular features in the first part. Maybe we can just think of a equi-replicated binary proper block design, whether supplemented or extended supplementary. We do not really need that lambda constant. That is the point. So, you have to examine, is there any need to have BIBD, or is it enough to have equi-replicated binary proper block design? Okay? That is the question here. Let us look to the MCQ straight away. So, the first one says, in the implementation of supplementary BTR technique, supplementary means just adding A on that side, it is not necessary to have the same number of respondents in each of the B blocks. Recall what we have done here, we wrote small n equal to 12 times n star plus n0. That n star was the same number of respondents in every block. That is what we had. So, the question is, in the implementation of supplementary BTR technique, it is not necessary to have the same number of respondents in each of the B blocks. Is it true? Is it false? Or does it depend on the design parameters BVRK lambda? That is the question number 1. Okay? What is the question number 2? In the implementation of extended supplementary BTR technique, the first one was referring to supplementary BTR. This time it is extended supplementary. That means in the leftover part, you take all the leftovers and A and make a choice of one out of them, 1 plus k, but that one is out of V minus k plus 1. That is the idea of extended supplementary. In the implementation of extended supplementary block BTR technique, it is necessary to have the same number of respondents in each of the V blocks, whether it is true or false or depends on the design parameters. Okay? The third question is also quite interesting. It says that imagine V equal to 2k. So, in every block you are taking half and you are leaving half. But which half do you take? So, if V equal to 10, do I take 1, 2, 3, 4, 5 or do I take 6, 7, 8, 9, 10 in one block? Whatever I am saying, you can immediately ask, sir, why this one, why not the complementary part? That is also of size, same size, because V equal to 2k. That is the idea. For V equal to 2k, block formation is a critical issue, since each block has two alternative solutions by looking at the dual of each block formation. As I said, if V equal to 10, I started with a block having 1, 2, 3, 7, 9, you can immediately say, why not 4, 5, 6, 8, 10, the complementary part. Because I can look at the block formation, I can also look at the dual of the block formation. Which one do I take? Is it a critical issue? Do I have to really strike my head to find out which one is better? That is the kind of question that is coming up. It is because V equal to 2k. Otherwise, if V is not equal to 2k, you know that one is k, other is V minus k. You do not have to worry about which one to take. Anyway, they are unequal. It is not critical for estimation of PA. It is indeed a critical issue. It may be critical for some BIBDs. So, these are interesting MCQs here. I am sure you have the answers now. The answers are already given. But you have to think more than that. You can see the answer, but you have to develop the logic. Why is it true? Why is it false, etc. Okay? So, stop here. Very good. Thanks for your attention.